Myself Satish. Hi, myself Satish, and I guess there are 12 participants in this breakout room. Uh, so, yeah. So before I begin, if I could just get a brief, if you could probably all jot down what your expectations are from this session, and since there are less number of people, probably some of you could capture your education profile or what is your existing profile. It will help me to tune my content better.
Hi, Satish.
Hi, is this Amit?
Yeah, my name is Amit, but I am not a student basically. I am the father of a student basically.
Okay, sir.
And my kid is at present in school basically, so he is not attending the session basically at present.
Okay, sir.
So basically, he is interested in robotics, coding, and programming, plus the mechanical part of the robotics.
Okay, sir.
He is at present doing IBDP in an international school.
Okay.
So I am looking to send him next year down the line to US or outside India, basically for the undergraduate programs.
So he's in class 11th or 12th.
He is in 11th at present.
Okay. Okay.
So I'm looking for basically that robotics part. So that's the main reason I'm connected to this meeting basically.
Okay. Okay, sir.
So I
Okay.
will need your help regarding some universities in US and Canada also for the same basically.
I would not have much idea about Canada, but yes, I have a fair bit of idea about universities in US. So
Yeah.
I'll from that definitely. Sure.
Thank you. Thank you.
Yeah. Anyone else would like to jot down their expectations?
Yes, sir. May I?
Yeah, sure. Please go ahead.
Hi, good evening, sir. Actually, currently I have completed my grade 10 and I study in an IGCSE school. So now I will be starting my AAS and A levels in the month of May. Most probably, currently I'm not really sure about what do I have to do, but I'm really interested towards computer science and coding, robotics and stuff like that. And I'm planning to go to US or Canada the same for my undergraduate studies. So even I wanted the same kind of guidance, the way uh,
Sure.
he wants it. Yeah.
Okay. Anyone else?
Hello.
Hello. Yeah.
Yeah, I want. Is this like about artificial intelligence and all, making robots
So
for
AI is
artificial?
AI
Yeah.
is a part of it. Yes.
Uh, yeah. So I was not sure if I should take AI because there are like many people who go for it, but not everyone gets.
Okay. I
Like
didn't.
there's a percentage. Like some people only get in that. Out of some 100% people who go, only 10% get. Like it's hard to get in that because you have to get a PhD and
Okay.
years of hard work. So I'm not sure if I should take it.
Okay. Uh, okay. I'll try to touch that, but I'm not sure if I'll be able to answer that question. Yeah. Sure. Anyone else before I can probably begin?
Can I go?
Yes.
So I'm Irie from Japan, and I'm currently a senior for American school, and then next year I'm planning to attend University of Wisconsin Madison for measuring like engineering computer science. So I just want to like know like kind of like ahead like what's going like what is like thing like I'm going to learn about like robotics those stuff, so that's why I joined today's like session. Yeah.
Okay. Okay. Great, Ivy. I'll try to touch upon what you could probably expect in robotics.
Okay, thank you.
Yeah. So I'll begin, and if anyone has any specific questions, they can probably ask. And I'll just give you a brief overview of how robotics as a field has evolved, Now, my overview would be more of a practitioner's overview because I have been associated, I have been working in this company called Addverb. So what do I feel from a practitioner's point of view, and what have been my experiences? So I can touch upon that to show you the evolution of robotics as a field. So if you see, Japan has had a very big role to play in evolution of robotics, along with some European nations and definitely US. So earlier, so if you see, robotics as a field started to catch up in 1970s and 1980s with the onset of computers. And first, we had onset of static robots, which are basically 4-degree or 6-degree robotic arms, which are just like human arms that were primarily used in auto industries, right? For operations like welding, for operations like assembly of body of the car, and all those operations. There were established companies for this, companies like ABB, companies like ABB from Sweden, KUKA from Germany, Yaskawa from Japan, and these companies were, there were other Japanese companies as well apart from these companies in Europe who were making these static robots. And these static robots typically used to be caged robots. So any application that you see, the robot will be caged because the intelligence level of these robots was not very high. And then that's why they had to be caged, because they could not differentiate between humans and machines. Subsequently, with advancement in computation capability and advancement in computers, these robots became more collaborative in nature. And the world also, so these robots were static, and the world also moved towards mobile robots, right? And that is what is catching up today, and that is what we are also present in, which is basically your autonomous mobile robots, or mobile robots that can move and perform your tasks, right? Now, this field has a very wide application. The application that we are present in, which is basically mobile robotics application, is of factory and warehouse automation. So when we say factory and warehouse automation, to understand it in a very small or very precise way, the robots that we build work within the four walls of a factory or a warehouse, right? That's why it's warehouse automation or factory automation. And the robots that we build basically pick material from one place and take it to any other place. Either that can happen horizontally, that can also happen vertically, right? So we build our own hardware and we build our own software. But the industry trend that is happening right now is that hardware is becoming more white label. When I say white label, there are companies which only make hardware, and the differentiator is now becoming software. So there was a question or an expectation where there was a gentleman called Mr. Amit who said what kind of mechanical design his son should work on. So, sir, primarily what is happening is the robots are getting differentiated on the basis of the algorithms that drives them, on the basis of the intelligence that is built into them, on the basis of the software that controls them. And there are effectively companies which only manufacture the mechanical part. That is where the field is evolving to. So if you would ask me in terms of career choice, what would be at today sitting here, what would offer him more opportunities or more diverse opportunities? It would definitely be the software portion of robotics, right? So robotics can probably be classified into three categories. One is the mechanical design, which basically is the cover, the components inside the robots, the wheels, the turning mechanism, etc. The second is the embedded system or electrical electronic component, which basically comprises of scanners, specialized sensors, cables, etc., that control a robot. And then third is the software layer, right? So software not only controls the robot, but also controls the fleet of the robots, right? So typically any robot that would be deployed at any location would comprise of a fleet of robots. So there is a central system which controls which gives command to different robots as well as to what kind of actions do they have to perform. Now, what could be ancillary application of robot, or what could be applications of robotics? So robotics is finding application in every field today, right? So basically, any repetitive job which does not require use of emotion or subjective judgment can be automated with the help of a robot, right? That is the basic principle of application of robotics. So if you see, robots are being used in medical profession, they are being used to carry material from one place to another. They are also being used for invasive surgeries. There is a company called 𝐑𝐴 which makes robots which perform surgeries. Then there are applications of robots where robots perform sonography or ultrasound. We have a robot which performs ultrasound remotely. There are robots that have UV lights on them and can do sanitization of any location and kill coronavirus. There is a product that we also have called Decimator. So this is the kind of application in medical robotics. Then you have another field of exoskeletons, which is again an application of robotics, where you have intelligent exoskeletons who can help people with disabilities or different abilities, or who can help people who have walking problems or spinal cord problems walk again, or probably use their body parts again. This is another application of robotics. Then in warehouse and factories, already there is an application in which Addverb is operating, where you can move material from one place to another at different heights. You have application of robotics in military. So you are using a lot of robotics to detect mines. You are using a lot of autonomous vehicles. You have, so all the autonomous vehicle, if you ask me, are robots, right? So all the self-driving cars of Uber, Tesla, Google, whatever technology they are using, basically it's a robot, it's an autonomous car. So that is also an application of autonomous car that we are seeing lately since last 5 to 6 years. Then there is an application of robotics in underwater applications, basically below sea, sometimes to clean the sea, sometimes to check the depth, etc. Then there are application of robots for drones. So drones are also an application of robotics, where you can see really good applications in defense, for reconnaissance, or for photography, for geography, for temperature conditions. You can see application of robotics. So these are some of the fields in which robots are operating today. Now, in terms of a lot of, so some of you might have, so there was a question, AI is a field and very less people get an opportunity into that field. I think robotics is not just only about AI, but about a lot of other algorithms as well. So there are 3-4 basic things or basic tools or basic streams that you should focus on while if you want to pursue a career in robotics. For those of you who are still in school, I would very strongly, very strongly recommend first robotics competition. So this is a competition that happens globally, where school students are provided with kits from this organization, First Robotics, and they can make robots from these kits, participate in a competition globally. Sorry. So participate in competitions globally, and it will be a very good exposure at a very young age for all the kids who are in class 10th, 11th, 12th, or 9th, 10th, 11th. I have seen students as young as studying in class 7th and 8th and participating in these competitions. Those are few and far in between. But definitely give this a shot if you're interested in robotics. It will help you get a flavor of how robotics works. So it's I'll tell you the name. It's called First Robotics Competition. Yeah. So this is a competition that can give you global exposure. There are teams that are participating from India already, globally also. So it's a different format. There are teams which compete within India, and then the team which qualifies goes to US to compete. There is an entire website which is available for them. If you search First Robotics Competition, you'll find a lot of information about them. Those who are probably studying in India in engineering, or they want to do an engineering from India, there is a competition called RoboCon, which is basically a sort of a robotics competition in India. Welcome. So, which is sort of a robotic competition in India where people from all engineering colleges participate. It is only open for engineering students or engineering graduates who are pursuing engineering in India. So it is a good idea to participate in RoboCon. If you are pursuing engineering, it will help you get a lot of perspective. Now, in terms of talking about tools or subjects that you should probably opt for, so obviously you would need to take science. Okay, so in robotics, a lot of, so there's a question if I could probably touch upon some online competitions. To be very honest, this is my personal belief and I could be wrong. Online competitions are not going to help you a lot if you want to make a career in robotics. There could be online competitions or hackathons if you want to make a career in software engineering per se, but in robotics, you would need a physical robot at the end of the day to test out your algorithms. So online competitions might not bear a lot of fruits, right? So in terms of the kind of tools and subjects that you need to touch upon, uh, first of all, you need to have a background in science, which is basically physics, chemistry, and maths. Mathematics is very important in robotics, is what I have come to realize. If you ask me, basically, so this is my personal belief, but I very, very strongly believe software programming is a combination of arts and maths. So somebody who's definitely good in both should definitely opt for software engineering as a profession or as a career, because you have user interfaces for any software, which is your arts, and then you have user experience, which is basic mathematics, right? So robotics is also about mathematics and extensive application of mathematics, extensive application of algorithms. So there is a subject called data structures, which you study in engineering, where you study about different algorithms. I have personally seen application of those algorithms in solving many robotic problems while we were delivering solutions to our customers in India and outside India. So first of all, you need to have a background in science. Second, what I have seen is people who opt for mechatronics, people who opt for electrical, people who opt for electronics engineering. These are also some of the streams which help people to make a career in robotics in India and outside India. I'm not really very sure if Canada offers really good robotic exposure, but in terms of exposure, US has really, really good, uh, I would say, really good universities, which give some really, really good exposure to people in robotics. And just give me a minute, please. Sorry. Now, coming to mechanical design, right? So in mechanics, so the first portion of robotics is mechanical design. So a lot of people who want to make a career in only designing the robots, right, not controlling the robots, can opt for this stream, mechanical design. Now, what do you need to understand mechanical design? So there are certain tools and softwares like SolidWorks software, like ANSYS software, like CATIA, like AutoCAD, which designers use to create 3D model of the robots, to create individual components of the robots, and to create simulations to see whether those components will work in real life or not. So that is about the mechanical portion. In terms of controlling the robot or the software portion of the robot, what you should primarily focus on. So what the two languages that are extensively used in robotics are Python and C++. So these two languages have found application in robotics field, and you should really master these two languages very effectively if you want to make a career in robotics. These are two languages we use extensively. We use a platform called Gazebo for simulation. So it is very difficult to create a physical environment where you could find 500, where you could find 500,000, 1,500, 2,000 robots. So we use Gazebo for our simulation. So what happens is through Gazebo, we can enter some values and we can see and we can create a mechanical model of the actual robot. And then we can check whether our code is making the robot behave in the same way that we thought. So that is what we use. There are other simulation tools available as well. Then there is a operating system called ROS. Has anyone heard about ROS? No one? No issues. Yeah. So ROS is Robot Operating System. Just like we have Windows, there is a robot operating system which basically has different services and different functions. And a lot of programming that is done for robots uses ROS platform, uses robotic operating system platform, right? So that is also something that you should learn from. That is also something that you should learn, or you should focus on learning uh, from robotics point of view. Then there are SLAM algorithms, which you should definitely go through. SLAM stands for simultaneous localization and mapping, which basically means mapping the robot. So typically, if you see, yeah, I'll come to the hardware part of the robot. So typically, if you see, the robot is just like a human in case of mobile robots, and it can visualize the area around us just like we do through our eyes. So that is where it has to localize itself, and it has to map the area. So the name of the algorithm comes from there: simultaneous localization and mapping, SLAM algorithms. So this is also a field where people specialize. And then there are modules which are called perception and navigation module. So perception has more to do with creating a map. Navigation has more to do with the control element of how the robot is going to move, right? So this is about the software bit of the robot. Then there is a element of electrical, electronics, and controls. So there, I'm sorry, there are some people coming and joining, so I have to just admit them. So there, what you can probably look for is electronic engineering. If you want to make a career in electronic engineering, this is the kind of application you will find in robotics, where you would have to work with specialized sensors, safety sensors, LiDAR. So anybody understands what LiDAR stands for? Any guesses? Any attempts?
What stands for?
LiDAR, LIDAR. Have you heard this word before? LiDAR? Anybody has heard this term? Okay, no issues. So LiDAR stands for laser image detection and ranging. So basically, you can all go back and search about LiDAR sensors. These are specialized sensors which create a map of their surroundings in 3D. So the robot, so if you see all the self-driving cars, a lot of these self-driving cars, technologies that are available today, are working on LiDAR. So they are using LiDARs to create a 3D map. Then there are also depth cameras or special cameras which can replace LiDAR. That is also a technology on which people are working on. Then there are industrial PCs which process the data that is generated by these special sensors. And then there are programmable logic controls, PLCs. Then there are special memory cards which help the processing capability to remain in the mobile robot. So there are three streams that we have talked about. One is the mechanical design stream, if you want to make a career in robotics. One is the software stream, where I've extensively talked about what kind of, so in mechanical design, I've touched upon the kind of platforms that you should use. In software, I have touched upon the kind of languages that you should have a hold on, and the algorithms that you should focus on, the specializations that are available. And then in electronics and embedded systems, I have touched upon the kind of sensors and devices that you would be working on. So you can, a lot of people who are basically having mechatronics backgrounds, especially outside India. So in India, we do not have mechatronic field as common, but in US, mechatronics is pretty common. In Europe, mechatronics is pretty common. I'm sure in Japan, mechatronics would be pretty common. It covers both the mechanical design and the electronic elements of robots. A lot of people learn programming by themselves. A lot of people learn language and platforms by themselves. Now, coming back to the question about universities in US, so the best university, and this is my personal opinion, I could be wrong. This is my opinion from a practitioner's point of view, not from a academician point of view. And there are, we have a strength of 600 people. Almost 40 to 50 employees of ours have gone on to pursue MS from US. So based on what kind of colleges do they opt for, A lot of them have gone to pursue PhD from US. So based on the kind of colleges that they opt for, the kind of universities they apply to, this is the list that I have, which I feel students usually opt for while going from India. So the first is CMU, which is basically Carnegie Mellon. So this is the university. If you want to pursue a course in robotics, you should definitely aspire for this university. There is a lot of work that they are doing on mobile robotics, snake robotics, and you will have a very good exposure and experience. Second is Georgia Tech. You can also look for this university if you want to make a career in robotics. You can also look for University of Pennsylvania, which is UPenn. You can look for this university if you want to make a career in robotics. Then there is MIT, where you can go if you want to opt for a career in robotics. Worcester Polytechnic Institute is something that is again known for robotics. Then University of Maryland is something that you can look for. University of Michigan that you can look for, and the Northeastern University that you can look for. These are some of the universities outside US. The university that I am aware of is NUS, National University of Singapore, which works on aerial drones extensively. In India, if somebody would like to pursue a course or a career in robotics, the colleges to go for are IIT Chennai, which has a specialized course in robotics for masters, which is an MS. IIT Delhi, which has a special lab dedicated to robotics and is doing some really good work. And then IIIT Hyderabad, which is doing the best work in terms of research in robotics and is really doing an amazing work. Now, for those of you who are interested in computer science and robotics, I've already touched upon the kind of languages that you use. I think Python and C++ is something that you should focus on. Uh, C++ will also help you to get comfortable with object-oriented programming. So in future, if you don't want to choose, or if you don't get an opportunity to make a career in robotics, if you are fluent in object-oriented programming and data structures, you will get very good career opportunities in software engineering as well, right? Java, not a lot of people, I am not aware of people who are using Java for robotic programming. In terms of AI, it is used extensively in robotics. So what happens usually is when robots are moving, they are getting a lot of data, and you need to use a lot of models, extensive modeling you have to do. You have to use a lot of machine learning to make sense of this data, and to also use this data to create meaningful maps, meaningful decision points. So definitely AI has huge application in robotics. What is going to happen is, once 5G comes into the picture, the computing capability of robots are going to shoot up. Today, the limitation is of bandwidth. We do not have the requisite bandwidth to develop the computational capacity in robot. But once we have 5G, hopefully in India and outside India, the application of robotics is going to shoot the roof, and we will have extensive application of edge computing, which you might have read or heard on. And that is the next growth area for robotics, and that is the area where you could look for new growth. Now, coming to your question, Irie, in terms of robotics, I think you should also focus on learning on Python and C++, at least get an exposure there. Get a hang of ROS, which is Robot Operating System. And then if you are into designing, you could definitely learn SolidWorks and design some of the robot modules that you want to work on. Now, this is about the questions that you have asked. Based on this, if there are any particular questions or any particular topic that you want me to touch upon, I would be glad to answer them to the best of my ability.